Good day, students. Today, we will be discussing deriving the double and half angle formulas. In deriving the double and half angle formulas, you should use the other trigonometric identities, especially the sum and difference identities. For the learning outcome of this session, it is expected for you to derive the double and half angle formulas. Let us recall the sum and difference identities that we have derived in the previous lesson. Let us derive the sine double angle identity. In the sine sum identity, we let b equal to a, and we get sine of 2a equals 2 sine a times cosine a. So as you can see here, we let b equals a. So we have sine a plus a equals sine a cosine a plus cosine a sine a. That's why it became sine 2a equals 2 sine a cosine a. Sine double angle identity. The equation sine 2a equals 2 sine a cosine a is an identity as it is true for any real number a. This is called sine double angle identity. Now, let us derive the cosine double angle identity. In the cosine sum identity, cosine a plus b equals cosine a cosine b minus sine a sine b, let b equals a. And we have cosine a plus a equals cosine a minus sine a sine a. So cosine a plus a will be cosine 2a. So cosine 2a equals cosine square a minus sine square b. Cosine double angle identity. The equation cosine 2a equals cosine square a minus sine square a is an identity as it is true for any real number a. This is called cosine double angle identity. Now, let us recall the fundamental Pythagorean identity and its other forms. So we have sine square a plus cosine square a equals 1. The identity can be written as sine square a equals 1 minus cosine square a, or cosine square a equals 1 minus sine square a. Alternative forms of cosine double angle identity. Now, let us derive the alternative forms of cosine double angle identity. If we substitute cosine square a by 1 minus sine square a in the formula for cosine 2a, we get cosine 2a equals 1 minus sine square a minus sine square a. So now, it will be cosine 2a equals 1 minus 2 sine square a. On the other hand, if we substitute sine square a by 1 minus cosine square a in the formula for cosine 2a, we get cosine 2a equals cosine a, or cosine square a, minus 1 minus cosine square a. So it will become cosine 2a equals 2 cosine square a minus 1. We have obtained other forms of the cosine double angle identity. Here is the definition of the alternative forms of cosine double angle identity that was derived using the fundamental Pythagorean identity. The equations cosine 2a equals 1 minus 2 sine square a and cosine 2a equals 2 cosine a minus 1, or 2 cosine square a minus 1. So there are the identity that is true for any real number a, and they are the alternative forms of cosine double angle identity. Now, let us derive the tangent double angle identity. In tangent sum identity, tangent a plus b equals tangent a plus tangent b all over 1 minus tangent a tangent b, let b equals a, and we have tangent a plus a equals tangent a plus tangent a all over 1 minus tangent a tangent a. So it will be tangent 2a equals 2 tangent a over 1 minus tangent square a. Here is the definition of the tangent double angle identity. The equation tangent 2a equals 2 tangent a over 1 minus tangent square a is an identity as it is true for any real number a. This is called tangent double angle identity. Other identities in terms of cosine 2a. Now let us derive other useful identities in terms of cosine 2a that will be useful in deriving the half angle identities. From the alternative forms of cosine double angle identities, we can obtain some useful identities expressing sine squared a and cosine square a in terms of cosine 2a. So first, cosine 2a equals 1 minus 2 sine square a. So it will be 2 sine square a equals sine minus cosine 2a. So solve for sine square a, divide both sides by 2. So it will be sine square a equals 1 minus cosine 2a all over 2. On the other hand, cosine 2a equals 2 cosine square a minus 1. So it will be 2 cosine square a equals cosine 2a plus 1. So divide both sides by 2 again. So now it will be cosine square a equals 1 plus cosine 2a all over 2. We can also use the previous identities to express tangent squared of a in terms of cosine of 2a. So take a look. Tangent square a equals sine square a over cosine square a. So substitute 1 minus cosine 2a over 2 and 1 plus cosine 2a over 2 to sine square a and cosine square a respectively. So now you have tangent square a equals 1 minus cosine 2a over 2 all over 1 cosine 2a over 2. So eliminating the both denominator, which is 2, it will be tangent square a equals 1 minus cosine 2a all over 1 plus cosine 2a. Sine half angle identity. From the identities in terms of cosine 2a, we can derive the sine half angle identity. So from the identities expressed in terms of cosine 2a, so we can have sine square a equals 1 minus cosine 2a over 2. If we replace a by a over 2, we get sine square a over 2 equals 1 minus cosine a over 2. So extract the root in both sides of the equation. It will be sine over 2 equals positive or negative square root of 1 minus cosine a all over 2. The equation shown is an identity as it is true for any real number a. This is called the half angle identity. So take a look at the equation. Sine square a over 2 equals 1 minus cosine a over 2. Cosine half angle identity. From the identities expressed in terms of cosine 2a, so now we have cosine square a equals 1 plus cosine 2a over 2. If we replace a by a over 2, we get cosine square a over 2 equals 1 plus cosine a over 2. So it will be cosine a over 2 equals positive or negative square root of 1 plus cosine a over 2. The equation cosine square a over 2 equals 1 plus cosine a over 2 is an identity as this is true for any real number a. This is called cosine half angle identity. Tangent half angle identity. From the identities expressed in terms of cosine 2a, so tangent square a equals 1 minus cosine 2a all over 1 plus cosine 2a. If we replace a by a over 2, we get tangent square a over 2 equals 1 minus cosine a all over 1 plus cosine a. So tangent a over 2 is equal to positive or negative square root of 1 minus cosine a all over 1 plus cosine a. Other forms of tangent half angle identity. From the quotient identity, tangent a square over 2 equals sine a over 2 all over cosine a over 2. If we multiply the numerator and denominator by 2 sine a over 2, we get tangent a over 2 equals sine a over 2 over cosine a over 2 times 2 sine a over 2 all over 2 sine a over 2 equals 2 sine square a over 2 over 2 cosine a over 2 sine a over 2. From the sine half angle identity, sine square a over 2 equals 1 minus cosine a all over 2. And from the sine double angle identity, we have sine 2 times a over 2 equals 2 cosine a over 2 sine a over 2. Substituting to the equation, we get tangent a over 2 equals 2 sine square a over 2 all over 2 cosine a over 2 sine a over 2 equals 2 times 1 minus cosine a over 2 all over sine 2 times a over 2. So now we're going to have tangent a over 2 equals 1 minus cosine a all over sine a. To get another form of tangent half angle identity, we multiply the numerator and denominator by 1 plus cosine a, and we have tangent a over 2 equals 1 minus cosine a times 1 plus cosine a all over sine a times 1 plus cosine a. So as you can see, the numerator is in some indifference pattern, so it will be 1 minus cosine square a, and that is equal to sine square a. That's why our numerator became sine square a. Okay, so the denominator is sine a times 1 plus cosine a. Okay, so sine a will be cancelled, so tangent A over 2 will just be equal to sine A all over 1 plus cosine A. The equations tangent square A over 2 equals 1 minus cosine A all over 1 plus cosine A, tangent A over 2 equals 1 minus cosine A all over sine A, and tangent A over 2 equals sine A all over 1 plus cosine A are identities as they are true for any real number A. They are called tangent half angle identities. Now, here is a summary of the double and half angle formulas. So take a screenshot of this, save this in your smartphone. Always remember, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy, and God bless everyone. See you next time in our next lesson.